Imagine looking at a group of children playing in a park, but right in the center of your vision, there is a dense, dark blur. You can see the grass on the edges and the trees in the periphery, but the children you are trying to focus on have vanished into a gray void. This specific pattern of vision loss is caused by age-related macular degeneration, or AMD. It targets the fovea, the specialized area at the back of your retina responsible for high-resolution central vision. When the fovea breaks down, you lose the ability to read, drive, or recognize the faces of people standing directly in front of you. AMD affects roughly 1 in 7 Australians over the age of 50, making it a leading cause of legal blindness across the industrialized world. Curious, but why does the eye fail in this highly specific way? Why does the center of our visual field deteriorate while the surrounding peripheral tissue remains intact? This targeted blindness is the end result of a microscopic, highly localized waste management system that slowly suffocates itself over decades. To see how the system fails, we have to look at the healthy layers of the macula. At the top are the light-detecting photoreceptors. Beneath them sits the Retinal Pigment Epithelium, or RPE, which processes cellular waste. Below that is Bruch's membrane, a permeable filter, and at the very bottom is the choriocapillaris, the network of tiny blood vessels that feeds the whole system. As we age, the first domino falls. We naturally lose a portion of our photoreceptors, but more importantly, the choriocapillaris network begins to degrade and lose its vascular density. The tissue is suddenly receiving less blood. With a reduced blood supply, the RPE cells become sluggish. They struggle to digest the dead outer segments of the photoreceptors above them, and because they can't process this waste fast enough, a toxic granular cellular debris called Lipofuscin begins building up inside the RPE cells. This sluggishness slows down the transport of waste out of the retina. Lipoproteins are no longer efficiently cleared, causing Bruch's membrane to physically thicken and trap toxic basal linear deposits directly beneath the RPE. Because transport across this membrane relies on passive diffusion, that thickening chokes off the transfer of vital nutrients. The eye's internal plumbing is backed up, setting the physiological stage for a structural collapse. That trapped debris eventually manifests as drusen, small yellowish mounds that erupt beneath the retinal pigment epithelium, pushing the delicate retinal layers upward. These mounds are microscopic landfills, composed of over 40. The collapse of these drusens pushes the patient into late-stage AMD. From here, the disease fractures into 2 distinct pathways. The first pathway is geographic atrophy, or dry AMD. In this state, the retinal tissue simply thins out and dies, creating expanding dead zones in the vision. The second pathway is neovascular, or wet AMD. Here, in a desperate attempt to restore blood flow, fragile abnormal new blood vessels grow from the choroid and burst through into the subretinal space. These vessels leak fluid and blood, physically detaching the sensory retina. Whether the tissue atrophies in dry AMD or drowns in fluid in wet AMD, the mechanical result is identical. The fovea is destroyed, leaving the dark scotoma in the center of vision that we saw at the start. But patients do have defense strategies. Smoking is the top environmental risk factor, yet data shows that 20 years after quitting, a patient's risk drops back down to that of a non-smoker. Diet acts as another barrier. Adopting a Mediterranean diet high in leafy greens like spinach actively supplies the macula with protective carotenoids like lutein and zeaxanthin, which help absorb damaging UV and blue light. Modern medical interventions are also advancing. For wet AMD, regular anti-VEGF injections can suppress the growth of leaking blood vessels. And for dry AMD, emerging therapies like pegcetacoplan target the immune system's complement cascade to slow the expansion of atrophy. Biological aging is inevitable, and our cellular structures will accumulate wear and tear. But by treating the macula like a high-performance engine that requires constant waste removal and proper fuel, we can prevent those microscopic dominoes from falling and preserve the center of our visual world.